There. Okay, it is 3:35, so we are going to go ahead and get started. So, as I mentioned already, I am unfortunately the person that usually helps me out with tech. I had to be out today. So I'm on my own. So if you have any questions while we are going along, I ask that you kind of wait till we have a breaking point where I have you guys work on something, if possible, to ask the question. And then you could do so by unmuting is probably going to be the easiest way for me to see questions, but I will check chat as you are working through the questions if you have any, if you have any problems with it. So my name is Matt Steele. I am one of the research services librarians here at WVU. And what we are going to talk about today is we are going to give an overview of using R and RStudio. If you are unfamiliar with R and RStudio, they are a programming language who is specifically developed to help people work with data science and data analysis. So separate, the other open source freely available program that you can use to do a lot of these functions is Python. Now, Python was made as a programming language first that also has some packages that you can get to do data analysis, but its main function was not primarily built for data analysis. RStudio and R on the other hand, was primarily built as a data analysis program. When we download R, so R itself is the programming language. And here, as I opened it up, you can actually see what R looks like by itself. And we can run commands through R. We can get answers for that. And we can run basic things like grab a sample of something. So that is the actual programming language we are going to be using. But what we have in addition to R is RStudio. RStudio is basically the interface that makes it easier to use R. So if you think about it, you can think about it in the same way as how Windows and DOS work together. So before Windows, you would have to use DOS program and you'd have to manually find where everything is. Windows put a nice, easy to use layer over it that allowed you to more easily use the functions in DOS to access things like programs and to run programs and all that fun stuff. So R is what is basically doing the work. RStudio is going to be the nice layer that we put over it that makes our work a little bit easier. As I mentioned, my name is Matt Steele. If after this, and I will send out these slides after the workshop along with the recording. I know plenty of people have asked for that. If you want to get a hold of me, I always shudder to bring this picture up, but if you want to get a hold of me, you can look up Matt Steele WVU, and you can get a hold of me in a few different ways. The easiest is going to be email, or you can make an appointment. So as you start working on R, and I really suggest after you get done with these workshops that you start to apply it to your own work, because R is iterative learning, which means it gets easier and easier the more you just actually practice with it. But if you want to talk over how to do some things, how to do some more advanced functions within it, we get this really easy appointment button. We can make a Zoom appointment and talk through whatever you are working on. It's really easy to book. It'll show my available times and all that fun stuff. Additionally, if you have not signed up for it yet, today we are going to be doing just the simple, these are the basics of working with R. So how you do the fundamental concepts. Next week at this exact same time, we are going to be doing a data cleaning and analysis workshop. And then in 2 weeks, we are going to be doing a data visualization and presentation. So if you want to learn outside of what you learned today, if you want to learn some of the more advanced functions within R, I would suggest coming to one of those if you have not signed up for it yet. Additionally, there are a lot of, outside of this workshop, there are a lot of really good resources for learning how to do R. The official site for R, you've probably already gone to when you downloaded it. It's the Comprehensive R Archive Network, or CRAN. So they have a lot of really good learning tutorials on there. Additionally, Posit, which is the company that runs RStudio, also has their own learning platforms. One thing, though, that you might not know about is the library has a database that is called O'Reilly Learning Platform. And outside of databases that you use to find things like scholarship, the O'Reilly Learning Platform will actually allow you to look up courses and learn it. It allows you to look up material to help you essentially learn things. So if we just start to skim through here, you can see all the different learning materials that it has in it that they're just showing. They have it in 3 different ways. They have books, they have courses, and they have videos are their big ones. One thing I would really suggest if you are learning R is to look at the book R for Data Science. This is written by one of Tidyverse, which is one of the more popular packages within R, and R itself, one of their main architects / engineers, Haley Wickham, wrote this book, and it is a really good book on just learning how you do the various functions within R. They are very easy to read and provide you with examples and exercises within it for you to do as well. Additionally, they have a course in there that I really liked. It's called R Programming for Statistics and Data Science. It's broken up into about 5 to 10 minute chunks for each learning. Posit as well has their own YouTube page. This is more for learning some advanced functions in it, or for doing in specific tasks. Like they'll have a video on doing ANOVA using R, something like that. And then finally, R for Data Science has its own YouTube page as well. Again, these are going to be more case-specific resources. Here's how you do a linear regression in R, that sort of stuff. Some reasons to use R specifically is it's open source, which means it's free. You're not paying for a license like things with SPSS, Data, and RStudio. It's platform independent, which means it works the same for the most part on a Mac as it does on a PC or on Linux if you're using Linux. It allows you to create reproducible data analysis. Now, what I say with that is having somebody that started learning data analysis on SPSS, a lot of the time what you're doing in SPSS is you're pushing a button, right? You're within R, you are actually writing out the steps within your code of how you actually perform the data analysis. So anybody can look at your code who understands R and see all the steps that you took to create the analysis that you did. It's shareable. That goes along with the platform independent and reproducibility. You can share the code with anybody, and as long as they have R and RStudio, which is freely available, they can work on it. There's also programs in RStudio that you can write both Python and R code into the same document. Additionally, there are packages within R that allow you to export the data that you've been working on as proprietary files, either Excel, Stata, SPSS, or SAS. So you have somebody that is working on it, but they are working on it in those types of files or in those types of programs. You can still work on the data with them along with it. So you can import and export proprietary files within it. And because it's open source, that allows additional people outside of the main architects of R and RStudio to create open source packages, which these packages can do specific tasks within it. If you come to the session next week, we are going to look at Tidyverse, as I've already mentioned before. Tidyverse is one of the main packages for doing data cleaning, analysis, and visualization. So it's got a bunch of built-in functions that allow you to easily perform these tasks. And it was created specifically for data, statistical computation, and graphic export. So that was the main reasons that R was created, was to do these tasks. Okay, so let's go ahead and get started. On your own computer, go ahead and open up RStudio. Close that up. And you should, let me open up participants, okay. And you should see a screen very similar to mine. Everybody able to see my shared screen okay? I haven't seen anybody say any different, but.
Yes, we can.
Thank you so much. And when you get done opening up RStudio, you could just maybe do the raise hand. So I just know when we get most of the people that are done doing it in your Zoom, I think that'd be the best. So to open it, you should be able to open it either in your start menu on a PC or in your apps menu on a Mac, and you'll just open up RStudio. So specifically RStudio, not R, we are looking for. Okay, looks like a good chunk of you have got it open. So if anybody needs more time, please say so now. If not, we're going to go ahead and move forward. All right, you can go ahead and lower your hands too. All right, the first thing we are going to do on it is we are going to create a file. So when I opened up R before in the beginning, just base R, one thing that you might not have noticed is base R, that R program will allow you to run code and get an output. However, you can't save what you are working on. So one really great thing about RStudio is it allows you to create what they call scripts. And scripts are files that you save that you can come back to and work on at any point, and you can share with other people. There are a few types of ways. Did I have a hand raised for a question, or did I have a hand raised saying we're done? Yu Chung Chen? Was there a question? I'm so sorry. Okay, I'm going to move on. There are a couple of ways that you can create these code-based files. The first one that I mostly work with is what is called an RScript file. And an RScript file is a file that everything that you type into that file is interpreted as code unless you otherwise tell it not to be code. So everything that you are typing in there, the program is going to interpret as R code and try and run it as R code when you tell it to run. The other type of files that you could also do is an R Markdown or a Quarto document. These documents allow you to combine narrative text code and the output of the code into a single document. So with these documents, what happens is the program will interpret everything that you are typing in there as narrative text, unless otherwise told so. So unless you say, hey, this is a code of, this is a chunk code that everything in here should be interpreted as code, everything else will be interpreted. And this allows you to do a couple of things. It allows you to create one file that dynamically updates with your code. So if you are writing a paper, you can just write your paper in RStudio And it will completely update with the code, and you can export it as a PDF, HTML, or I forget the third type, but off the top of my head. Quarto is the newest iteration of R Markdown, so that also allows you to do the same thing. We won't look at R Markdown and Quarto documents today. If you are interested in creating one, it will be part of the third lesson of these workshops. So the data visualization and presentation will show you how to make one of these documents. For now, though, we are going to go ahead and open up an R script file. To do that in RStudio, you'll just go to File, New File, R script. So go ahead and on your own computer do that. When you are done doing that, just put your hand up to let me know that you've done it, and we can move on. And if you have any questions, these periods where I'm asking you to do things are a good time to ask you. Okay, looks like most people have done it. You can go ahead and lower your hands. As I mentioned, RStudio is like the nice layer that lives over R that allows you to interact with your code and see what you're doing with your code more easily than it does in the program. It's called an integrated development environment, or an RDE, and it allows you to save code, store your variables and your environments, and view the outputs that you are making in an easier way than R. There's a few things to get used to as you are working with RStudio. The first is up in the pane in the top left, which should have opened as we opened up our new document, is what is called the source pane. The source pane allows you to, this is where you will see the script file or markdown file that you are working on. So this is the area that you create your script that you can run then at any point. Just below it, you're going to see the console panel. So the console panel is where R is actually running. And these are when you actually, when you run. Did I have a question? Sorry, I see a hand up. Do I have a question? No, okay. When you run any interaction in R, this is where you will see the results. So down here, you can see that this is the console pane. You'll get a couple of things in there. You'll also get a terminal, which is like a bash shell. And you'll get any background jobs that are currently running. So if you are running some code, it will run in this area. So if I want to know the result of 2 + 2 = 4, if I run that line of code, and we will talk about running lines of code in a little bit, but this is where you'll then see the output. So 2 + 2 = 4. It is also an area that you can type directly into. So you can type directly into the console, and it's a good place to kind of experiment with some of the code that you're running just to see if anything is working. It's also good for exploring the actual output of your data. Off to the right, up at the top right-hand corner, is what is called the environment pane. We're going to talk about creating objects and creating objects specifically within your environment in a little bit. This is where you'll see all the objects that you have created within this current session of R, or within your current environment that you are running. So you can view functions, objects, and data sets that are stored. This environment can be saved and accessed at any point, and it will save to your working directory. We'll talk about working directories in a little bit as well. And then finally at the bottom is what I just kind of call the miscellaneous pane. It's just kind of the catch-all for what you'll have. So this is where you can view your working directory and what files exist in there. Also, as you start doing data visualization, it's where you'll start seeing things like plots. I talked about packages early. You can see any packages available to you through CRAN, as well as what you have currently running within it. And then a really good one here is where this is where you'll get the help tab. So if you have any questions while you are working, I'll show you specifically as we start working on functions, how to get help on the function that you are working on. Okay. So the first thing that we are going to do before, and this is something every time you start a session of R, is something you'll want to do. And really quickly, let me define what a session of R is. A session of R is any time that you start up RStudio, it will start a new session of R. You can also start a new session of R by terminating R, restarting R, or quitting your session and starting a new session. Every time you start a new session, your working directory unloads, or every time you end a session, your working directory unloads, as well as any packages that you have loaded up outside of base R will unload. And this is just to help with your own computer, right? You don't want all these things running into the background. Once you are not working on RStudio, you want all this stuff to unload to save from taxing your computer. So that is one reason that we have that. The working directory is going to be the file folder that you are working on. And now working directories are important for a few things. Everything that we export is going to go directly into the working directory. And it also makes it so when you are reading files into R, you don't have to type the full path into it. It knows you are in this working directory, so it sees all the files in there, so you just need to put the file name in it. So to set our working directory, we are going to go into, and let me quickly view. Okay. So really quickly, we are going to go into session to set your working directory. You'll go into set working directory and then choose directory. Now from here, you are going to choose where you downloaded the lesson files for this computer. So through GitHub desktop or through GitHub, you should have downloaded the lesson plans for this session. All you're going to do is remember where you save that to. So mine is in R projects, and it is in first steps online, R first steps online. And I'm going to go ahead and open that. When you successfully have done it, you should get in your console pane a command that says set WD and the path to the folder. So go ahead and on your computer, set the working directory. Again, you'll go to session, set working directory, choose directory, and then on your computer, you are going to choose what directory you have it saved at. If you have any questions, feel free to ask. You'll know you did it right too. In your files pane, it should have these files opened up. And when you get done with that, again, feel free to raise your hand and let me know. And again, if you have anything that I need to go back over, please do so now while we have a chance. I see we have some new people that have come in. So things that we have done, we've obviously opened up RStudio. And then we've created a new file by going new file in our script. And then we're setting right now the working directory by going to session, set working directory, choose directory, and then you'll choose the folder that you downloaded the files for this session to. One thing that I will say that I like to do if I am working on a script that I know that I'm going to be coming back to quite a bit is I like to take this setwd command and put it at the top of my script. Every time I open up a new session, I just have to run this line of code and it'll set my working directory to what it is. All right, it looks like most people have gone ahead and set their working directory, so feel free to lower your hands and we will move on. Couple things to get used to because you are going to be using, you are going to be typing out your code. It is honestly a lot of typing. It is a lot of using the keyboard. Is getting used to keyboard shortcuts. One way that you can see what keyboard shortcuts are available to you is to go into Tools and go into Keyboard Shortcuts Help, and you'll get a listing of all the shortcuts that are available to you. Some big ones to know, though, to get used to using all the time. To run a line of code. So this is important. When you type something into your script, when you type something into your script, it doesn't automatically run that line of code. It's very important to remember. It doesn't run the code until you tell it to run the code. You can run the code by clicking on the Run button up here in the top right-hand corner of your source pane, and that will run the code. So you see it brought it down to the console. But the easy way to get used to doing it is to use the keyboard command, Control Enter on a PC, and I believe Command Return on a Mac. That will automatically run the line of code that you are currently on. When we start talking about object creation, another thing that you'll use quite a bit is what is called the assignment operator. So this is the line of code that will allow you to create an object out of something. That keyboard shortcut, and that is one that I use all the time, is Alt -sign on your PC or Option -sign on your Mac. And then one we're not going to use today, but it is one that as we start to do more advanced coding, especially as you start doing data cleaning and linking functions together, is to use what is called the pipe operator. When you come to next week's session, we will be talking about the pipe operator quite a bit. It is Command-Shift-M on the PC, and it is our Control-Shift-M on the PC and Command-Shift-M on Mac. So these are things you don't need to know how to code, but they make your life easier as you start to work on these things. The other thing that is important to start getting used to is, as I mentioned when we first started, in an R script file, everything that you type into an R script file is interpreted as code. So if I type native text in there with no connotation, I'm going to get an error message that says, I don't understand what you were trying to do here. To exclude lines of code from being interpreted as text in an R script file, we use the #. That will comment out the line of code. So it'll tell R to ignore this line of code. If I try and run this, it just ignores it. Until it sees a command. So commenting is important because commenting, a lot of the time, you might get a document that has 16,000 lines of code that took you, a few weeks to write, and, from chunk 100 to 150, you might have forgot what you were doing in that. So a lot of the time, especially as you're starting off, what I suggest doing is putting a comment code putting a comment code and say, oh, when I look at this, I know what I was meaning to do here. I forget. So you can look back and say, oh, for here, I was trying to get the meaning of this particular thing. So just a way to keep track of what exactly you were doing in particular contexts is important. Okay. Do we have any questions so far? Next, we're going to get into the three big things: functions, arguments, and objects. So these are the really important things. This is what is fundamental to learning how to use R specifically. The first thing to learn is functions in R. You can think of functions. The analogy that I like to give is think of R or a package in R as a toolbox. And the function would be like if you reached in the toolbox and said, hey, I need to hammer something. So you run in and you go in and you pull out a hammer. The hammer would be the function. The function allows you to do things. So if you look at these examples here, the function is sample. It's saying, hey, I want to grab a sample of the range of 1 to 5,000. The function here is the mean. It's saying, hey, I want to grab the mean of these three numbers. The function here is saying the str. It's saying, hey, what is the structure of this particular number? So functions are how you tell R to perform a task. So if we go into RStudio, we can try it out. Now, there are two ways that functions work. The way we are going to be talking about functions today is the built-in functions within specifically base R. So what functions do they have built into it that allow you to do something? So let's try out a function. Let's try and grab the sample of the range of 1 to 5,000. So go ahead, go into your R, and you can do any number for this if you want. So you can do 1 to 2,000, whatever you want to do. So go ahead and go into RStudio, and you'll type out the name sample. And one thing that I want you to note is as you are typing it out, notice a few things. First, it's going to pull up here some available functions based on what you typed in. So right now it's saying within the package base R, which is the only one we have loaded up, there is a function called sample. And this is what sample will allow you to do. So you can try that out. You can do sample, or you could try out mean, or you could try out, do we have random? Yeah, so try out function sample or try out mean. I think you can do round if you really want to. So try out one of those and just kind of see, and then you'll run the line of code with the run button here. And if you have any questions, please let me know, either in mute or ask in chat. Okay, any questions so far on functions? So functions are how you tell the program, here's the task I want to perform, right? I want you to grab a sample. Arguments are how you tell that function to operate. So think of it as you grab that hammer out of the toolbox, you say hammer at a 90-degree angle, hammer nail at a 90-degree angle, something to that nature. So same thing with arguments is how do you want that function to perform? And each function will have their own arguments built into it. So if I go back into RStudio and I go back down to our sample, remember I said, okay, so sample, when you start to type it in, it'll give you what is available to you. It'll give you what it does. But then here, it will show you all the arguments that go into it. So everything here separated by a comma is all the arguments that you can put into this current function. So X will be the data that you are putting in. So that will be 1 to 5,000. Colon and R is a range. Next, it will have the size. So how many samples do you want to grab? And then next will be replace equals. Now, when you see things like the replace and the probability where it has equal and it has an actual value attached to it, that will mean by default, if I don't put anything in there, it will not replace values. So once a value is taken out, it won't replace it, and there's not going to given any weight to the probabilities. So if I go ahead and run this, it'll give me a sample with 50 sample size that I've grabbed, and this will be a random sample. Now, when you are working on functions and wondering what functions do, one thing that is really important is that you can really, and this is one thing that I really stress with using R, is the ability that you have to look through the documentation. You can look through it in one of two ways. And we'll go back and let you try out some arguments as well. But before we do that, documentation is really important because one thing about R is it's not straightforward to what you are able to do in R. And the way that you find out what you are able to do is to do the documentation. So what functions are available to you? There's nowhere that says, if you open up R and RStudio, there's nowhere that says, here are all the functions that you can use. Here's a listing of it. What you need to do then is rely on the documentation. So base R will have its own documentation into it for all. And when I say base R, that is the package that you get without any additional add-on packages installed. So when you download R, you get base R with it. So if you want to run the array function, here's how you run the array function. And this is what the array function will do. And here are some examples of running an array function. As you start to get used to using R, you'll start adding on more packages. So we talked about tidyverse. If you come next week, we will be working a lot with tidyverse functions. All the tidyverse packages have great documentation for it. So if you were using dplyr, which is the data manipulation tool within tidyverse, you can see all the functions that are available to you in dplyr. So if I want to create new variables based on my observation using the mutate function, I can see what is there, what arguments that I need to put into it, and some examples of how it is done. The third way of doing it, and probably the way that I usually most commonly use in going onto an internet browser, is using the question mark and the name of the function. So if I wanted to know how to run mean, if I do question mark in the function name, it will open up in the help pane, in the help tab of the miscellaneous pane. this documentation for it. So I can get everything that I was getting on the documentation, I can also get just in R with the question mark and the name of the function. All right, so let's try out some arguments. So maybe try out sample, and then try out adding some arguments. So try adding a size, see what happens if you replace equals true, that sort of thing. And if you have any questions, please let me know. Oh, one thing I also wanted to suggest, I'm sorry, the tab button becomes really important too. If you hit tab while you're typing things in, it'll do a few things. It will auto suggest and it will auto populate based on what you are trying to do. So if I just go into the parentheses right now and I hit tab for the sample, it will list in order all the various arguments that are available to me. So if I want to do x equals, it will also tell me what these are doing. And I'll show you later, the tab will also autofill. Another thing that I need to mention as we talk about arguments is that R is a very order-specific program. So order matters within R. So if you look at the arguments that are available to us, in the first spot is X, in the second spot is size, in the third spot is replace, and in the fourth spot is probability. So I can do 1 to 5,000, and then I can do 50, and then I can do true, and I can do null. So by default, R will understand that this is X, this is size, this is replace, and this is probability, because that is the order that the arguments are written out in. However, you can also, if you feel more comfortable, you can say X equals 1 to 5,000. And then you can say replace equals true, and then you can say size equals 50. So if you are playing around with the order of things, if you label the argument, it doesn't make a difference where you put it. If you don't label the argument, it does make a difference. So it's thinking right now that true is sitting in the second spot, so it's trying to find a size argument for it, if that makes sense to people. All right, so play around with it. If you have any questions, please let me know. Okay, any questions so far with functions or arguments? So just to recap really quickly, function is the task that you want to perform. A function is a sample. I want to grab a sample of something. Arguments are the parameters or the directions that you give to the function. I want to get a sample of the range of 1 to 5,000. I want it with a size of 50. All arguments are separated by commas. And order within the arguments matters if you are not labeled. If you want to label it, then the arguments order does that. Next thing we're going to talk about, unless there's any questions about those two, is the third big thing with learning R. And that is the idea that you can store information into what is called an object. So back to the analogies, the idea I like to think about with this is that this is like you have a gigantic file cabinet, an infinity file cabinet. And you can think of objects as drawers that you can store information within. So if I go back into my file, you can call objects anything. I will talk about some best practices with naming an object, but for now, let's just call our first object we're creating A. And then I'm going to use the assignment operator, which is alt minus sign, and I believe option minus sign on Mac. Or you can just do backwards caret hyphen, either work. So this is saying right now, create a new object and call it A. And then everything after this is what is going to be stored in A. So let's just do 5,000 times 5,000. Great. So if I go ahead and run this line of code, we'll now have A with the stored value of this. Maybe let's do an easier number, 50 plus 50. One thing to note about objects, as I just kind of demonstrated, is every time you run a named object, if you run that line of code, it will overwrite the previous value. So if I did for my first one, 50 plus 50, we got 100. If I change that to 50 plus 52 and I run that line of code, now A is being stored as a value of 102. So it overrode that 100 and there's no way to get it back unless you just change it back to 50. Now that object right here, this object has the numeric value of 102 stored in. So if I add that to 42, I'm going to get 144. The easiest way to see it is to store numbers in there, right? You can easily see that there's a number stored in there, but you can do all sorts of things. You can store words into it, so. And I will talk about creating strings later, but now the phrase hello world is stored in B. You can store tables, so we'll talk about loading data sets into R later on, and you'll store those as objects. And you can store functions as it, you can store multiple steps that you are running as it. So if you run multiple functions together on something, you can store all those functions together. It is, at its heart, it is a shortcut in some ways, but it is, in its easiest way to understand, it is you are storing information. Like you are opening up a file drawer and you're putting that information in there. So anytime you say R, you can pull it back out. So let's go ahead and let's create some functions on your own. And you can call them, I would start off with just ABC, but let me really quickly, let me see if this is the next one. So assignment operator, and then let me just talk really quickly about naming objects. But as you try it out, you might want to just say A, B, or C. Big things to pay attention to is to use descriptive and meaningful names that indicate the purpose of the object. So if you are working on, let's say, a workshop report, I might call the objects that I'm loading in workshop DF or something like that. So I know when I look back at it for my own personal, when I'm looking back at the values I've stored, and I look at the workshop data frame, I'm like, oh yeah, that's where I stored my data for the workshops. use lowercase letters, do not use uppercase letters. R typically is not a huge fan of uppercase letters. So while you can call it workshop EF, I would suggest not doing it. Just because R doesn't like it. Typically, you won't necessarily see it right away, but it's best to use lowercase letters. And then you have to separate words with a character. So I can't do workshop space DF. Because it will interpret this as it'll try and look for a character. So typically combine, if you have two words in the object name, combine them with an underscore or a period or a capital. My personal preference is underscore for when I'm working with data and periods when I'm working with visualizations. That is just my own personal priority of yeah. And then avoid using reserved words for functions. So don't use things like if, else, for, function, mean, sample, things of that nature. Like don't call an object mean, because R will want to see that every time and try and run the mean function. So just try and avoid those as much as possible. So go ahead and let's try and create some objects on your own. So you can even go back to our sample and you could store our sample as an object within it. And if you have any questions, please feel free to ask. Yes,
I have a question.
yeah.
How do you erase a previously saved variable, or in this case, object?
To erase an object, you can't necessarily, you could erase you could clear the whole list. You can't erase it, but you can overwrite it.
Okay,
So right
thank you.
now I have that as a sample. If I just change it to 500, right now it is holding the sample with 3 integers within it. Now I'll just change it to 500. So it takes the last thing that you put in and overwrites it. Good question though, thank you.
Yeah, so I noticed you have been skipping a space. Does it matter? Or like you skip spaces like 18, you left a space to go to 20. Is it okay, or is it also part of what we should learn?
Uh,
Like, is it compulsory you leave a space till you go to the next one, or you can just module everything together?
so you're saying, does that work?
Yeah, does that work?
Yeah.
Okay.
I would get used to, I mean, just for seeing what is going on. I think it looks easier with spaces, but it's completely up to the user.
Okay.
Now, spaces are important, and we'll talk about characters. Spaces are important with characters. So if I'm creating here, I'm saving a string variable, or I'm saving a string into B here. Then spaces are important. You create strings with quotation marks, and then everything within the quotation mark is interpreted as its own thing. So spaces become more important then when you. So you can see here that I put a space after the D, right? And that is being shown when I print it out. So if I remove that and run it, it's no longer there, right? So spaces are important when you start talking about using strings, but not as you write your code. If that makes sense. Okay, any questions on objects? So just to refresh really quickly, objects allow you to store information or tasks or data within a created name. And that name can be anything at all that you want it to be, but you should use the conventions. Make sure that when you come back to it, you know what that object is and what it does. So use descriptive and meaningful names. Based on R's, just how R likes things, use lowercase letters when you're creating an object, and then separate the words. My suggestion is to use underscores, but you can use periods or you can use capital letters as well. And then avoid using reserved words or functions. Okay, then the next thing that we're going to talk about is how R interprets what you are putting into. So there are several data types within data types within R. The first one and the most common one that you'll use is what R refers to either as a double or a numeric value. And these are your numbers, which can be integers, real numbers, numbers with decimal points, negative numbers, so on and so forth. So if I go into R, and I ask, what is the structure of the number 400? So structure is a function that asks you, what is going on with whatever is in the parentheses within the argument. It'll say it's a numeric variable and it's the letter 400, or it's the number 400. So that is the most common one that you'll look at. And once you start working with data sets, you're going to start seeing these data values will make more and more sense, especially as you start looking at your variables and whatnot. Characters are what R calls string variables. So we looked at those already with the hello world briefly. So you can denote something as a character in R by putting it into quotation marks. These can be either single quotation marks or double quotation marks. It does not matter, it interprets it the same way. Factors are what R refers to as categorical variables. So it'll be a sequence of numbers with some sort of predefined levels. These levels could be ordered or unordered. So things like male and female, or things like would be unordered, and things like socioeconomic or income level, would be something that is ordered. There are date values within it, like all programming or data analysis programs. Dates aren't the easiest to use in R, but Tidyverse has a really great package that is called Lubridate that if you are interested in working with dates, makes it really easy. And then there are Boolean value types. So Boolean will be your true and false. So we've already kind of looked at those. When we looked at sample, we said here that whether or not to replace the sample, if it is chosen, we gave it a data value of true. So you'll see data values that are either true or false. Those are called your Boolean value types. Okay. So another really big important function of R is the packages. Because it's open source, as I mentioned, it allows other people to create packages. And within these packages are a bunch of pre-built functions for you to use. So you can get a package that allows you to do ANOVA testing. You can get a package that allows you to do t-testing. There's a package for linear regression, so on and so forth. If you come to the session next week, we'll look extensively at the package tidyverse, which is used for data cleaning, data manipulation, and data visualization. So these packages are like toolkits. So think we have our initial toolbox, so that just has a hammer and a screwdriver. So you might bring in another package that has a saw in it or something to that nature. So it just allows you to do more with it. One thing that I really suggest with using packages are, no, that's not gonna be right. Within CRAN, so CRAN works in a couple of ways. It is a distribution center for R. It also has a bunch of really cool things, like it's got the R journal. So if you're interested in kind of what is going on with R, it's got a lot of great articles on it. But they also work, they're a consortium of people that work to make sure R is working at its best. So anybody can sit down and make a package. And you can download packages from lots of different places. If you are worried though at all about a package being vetted or being okay, what CRAN actually does is they will vet packages. So to get on the CRAN list, you have to submit it to CRAN and they have to make sure everything's working and it's not malicious in any way. So they do have a list of all of their vetted packages that they suggest that they've actually vetted within it. Is one thing to think about. You can also see a lot of these packages if you go into your miscellaneous pane and your packages tab, you can see a lot of these packages and what is available to you. And the thing to know about packages is to use a package, you have to at least one time on the computer that you are working on, install that package. So you only have to install a package one time. And you do that with the command install packages and the name of the package in quotation marks. So what I'm going to ask you guys to do is to go into your RStudio file and we are going to install that package and the word tidyverse in quotation marks. And then go ahead and run that line of code. Install. Install packages, of course. Once you go ahead and run that line of code, you should get a message underneath it that's saying if it is running or not. So go ahead and run the install packages tidyverse line of code. And when you get done with that, go ahead and raise your hand. Okay, go ahead and lower your hands. Now, while you only have to install the package once on the computer, so that is the only time. Now you guys all have Tidyverse installed on your computer. However, every time that you end a session, and just as a reminder, ending the session means you close down RStudio, or you go to new session, or you go to quit session, or you turn off your computer, or whatever. It will end the session and it will unload all packages. So every time you start a new session, you do have to load up, you do have to load up any packages that you may need to be using. So one thing that I also do every time I start a new script is I put all the libraries at the top. I put all the libraries at the top of the document that I'll need to load up. That way, when I get into the computer, I can just run these lines of code. I get everything all set up. So every time that you want to load up the package, you do need to call it when the session starts. So let's go ahead and you load a package with the function library and the name of the package that you want to load. So we're going to load Tidyverse, and then it should go ahead and load. So go ahead and use the library function to load up the Tidyverse package.
I have a question.
Yeah.
When you want to run your codes, do you have to run each line separately, or can you have multiple lines of codes and then run them at once? I don't know if that question makes sense.
It does. It will run it until it finds a stopping point. So when it sees a completed line of code, it'll run it until then.
Okay.
The second part of that is you can run multiple lines, so our multiple endpoints by highlighting and running it. And you can also use the code menu here. So let's say you have a full, you want to run like your whole script. You can just go into code and run region and click run all. And that will run everything that's in that script. So yes, by just
Awesome. Thank you.
clicking on run will do until an end. Highlighting it will do everything that's highlighted. And then you can see in code all the various things that you can also run. All right, some things that you might notice about when you loaded up a package. First thing is Tidyverse is a little bit unique. It's actually a suite of packages. So it'll say here, these are all the packages that got loaded up with Tidyverse. So you're getting dplyr, forecast, ggplot, lubridate, reader, string tibble, tidyr, per, all that thing. Another thing you'll see here is we got a conflicts message. Now, with functions, right, these packages are a suite of functions, suite of built-in functions that allow you to do tasks. Some things can only be named so many things, right? We have a function that's called filter that's filtering things out. Another package might also have a function that is called filter. So what we are getting here is that right now there's a conflict. There is the package we just loaded up, dplyr, has a function called filter, but a package we already had loaded in base R called stats also has one that's called filter. And right now it's saying that the dplyr filter is going to override the mask filter. So that's what that is telling you. You can run, however, a function, you can specifically target a package by typing in the name of the package and doing : and then typing in the name of the function from that package you want to run. And that will say only run it out run this function out of the dplyr package. The name of the package : is also a great way for you to see all the functions available to you through a package. So if I type in dplyr : I can see all the functions that are available to me through this particular package. And then you can start to type more. So if I'm looking for a mutate, which is creating new variables, you can do it that way. Okay. Any questions on packages? The next thing we're going to talk about then is creating data within R. I understand that not everybody will create the data within it. A lot of people will be loading data in, but this is, if you do need to create data within it, this is how you do it. And the main way we do it is vectors and data tables. So vectors in R are what they call arrays. And these are ordered collections of data items of the same type. So if we think back to our data values, in a vector, if you have numeric variable or numeric data in it, they all have to be numeric. And it is a one-dimensional array of information for the vectors. So if you think of an Excel spreadsheet, it is either, like a horizontal row or a vertical column, but just the one dimension, not two dimensions. And we can create vectors using the current syntax. So this one here is going to create an object and it's going to call it vector1. And within vector1 are going to be the data sequence 1, 2, and 3. So let's go ahead and create that. So if we go into RStudio and we create vec1, and we do our assignment operator, and we do C to create the vector, and then we do 1, 2, 3. And we run that line of code, we now have a new object. It is called vector1, and it has the numbers 1, 2, and 3 with it. We run it again, now it is 1, 2, and 3, and 4. One dimension with 3 items. One dimension with 4 items. And we can store anything in there, but you just have to remember that they have to be the same value. You are doing different type of values in it, you'll create what's called a list, which we're not going to do today. But you can also do that. So go ahead and try and create a vector and just put in it whatever number sequence you have. Just remember a couple of things. The numbers have to be separated by commas. And you use the C here to create the vector. Okay, any questions on vectors? All right, next thing we're going to talk about then is how you take these vectors and create a data table out of them. So if I have these four vectors here, title, year, length, and box office million. And then we go ahead and run that line of code. We can see that we've created a bunch of vectors in here. One thing to note about this is if you are combining them into a data table, they all have to be the same size. So box office million is a 1x3, length minimum is a 1x3, title is a 1x3, and year is a 1x3. If any of them were a 1x4, it would not be able to glue them together. They all have to be the same size. Once we have our vectors created, we can glue them together with the function data.frame. So this here is saying, create a new object and call it Star Wars.data. Then use the function data.frame. Let me just make this a little bit easier. Use the function data.frame and glue the created vectors together. And then if I run that line of code, if I call that, then I will have a data frame with those values with it. So we create vectors and then we glue them together essentially with the data frame. So think of a vector, each vector we're creating as a variable within your data frame. Now, data frames can have variables of different data types, but each variable has to have the same data type within. So title is a string variable. Year, right now, it's going to be interpreted as a numeric. We could change it to a date if we want. Same with the other two. Does that make sense? We can then see what is going on in the variable with subsetting. So subsetting becomes important. This is how you pull out variables from a data frame. And we subset with the $sign. Now, if we start to see, especially after we've created our variables, as we start to type in the name of the variable, we can see in our global environment, we currently have a Star Wars.data frame, and it'll even give you a preview of what that object looks like that we're storing our data in. And then if we hit the $sign, it will say, okay, we're looking in this data frame. These are what variables you have available in this data frame. We have title, year, length, box office. If we want to see what's going on with year, we can run that line of code and we'll see year. It's also a way that you can get things like descriptive statistics of a current variable. So the average length of the original trilogy is about 126 minutes. Now, one thing that's important to know about R, and especially as we start to read data into R, is that nothing on your computer is changing as you work on something in R. So right now, there is no data frame saved that has this information into it. We have to actually manually export anything that we've been working on in R. And to do that, we use the write.csv function if you're using base R. But if you have tidyverse loaded up, you can do the write_CSV. Whichever one, my preference is to use the tidyverse version, but write_CSV works just the same. Then we put the name of the object we want to export in first and what we want to call it and the file type. So we are going to export the Star Wars data frame as starwars.csv. We'll run that line of code and we'll open up our files and we'll reload here. And now we have the Star Wars.csv file in there. That was just modified now. Okay. Any questions on exporting or creating data? All right, the last thing we're going to look at then is loading data into R. If you come next week, we're going to work a lot with loading data and specifically then manipulating the data that we're loading in. My personal preference, and this is my personal preference, is to load data using the read_CSV function from tidyverse. So you have to have tidyverse loaded up to run this function. There is a read.csv that is in base R. It is clunky and it is taxing on your computer. So especially if you're loading in bigger data frames, I really suggest using the read_CSV, which is easier for your computer to handle. So we have right now a data set within our working directory file called fight-songs.csv. If we want to load that into R, if we want to load that data into R and start working on it, we'll first create an object and we'll call it fight_songs. And then we'll use the read_CSV function and the name of the file in quotation marks. So if I just hit F and I hit tab, it'll see, if I just hit tab, it'll show you all the files that are available to you in your working directory. So I'll just choose fight_songs and I'll go ahead and load that up. That'll create up in your environment a new data object that is called fight_songs. You can see it has 65 observations on 23 variables. And if we want to see that data frame, we can just call the object by typing its name in and running that line of code. And you can see here, we have the variable school, conference, so on and so forth, what type of data value it is, and then the observations we have within it. This is just going to give you a snapshot view of what is available to you in the data frame. You can see here it's got 14 more variables, and it'll just give you the name of the variable and the type of data value that it has on it. So go ahead and on RStudio, I understand that it is 5 o'clock now. If you need to go, I understand. I'll probably go for about 5 more minutes if you want to stay. But go ahead and on your computer, if you're staying, go ahead and load up the fight_songs data frame. If you didn't install tidyverse when we did it, you could do the read.csv file. And I can actually show you why I think that's clunky. So you can see how that one loads in here. And if you have any questions, feel free to ask. Okay. Next thing then is exploring the data that is available to you within it. So exploring what is going on in the data. One that I really like that I tend to use a lot when I'm doing my own work is the view option. So as I mentioned, you only are seeing a snippet of the data here within it. But if we use the view and the name of the object, it'll open up a new tab in RStudio that'll have the full data set within it. So all the variables and all the observations. You cannot manipulate what is going on in here. It's just for seeing, but you can filter. So if I wanted to just see, say, 12 schools within it, you could do that. But it is more of a way just to get an overview of what is going on in the data frame or data set. You could also do things like num column. You can also do things, I think these are a little bit older, but number of rows, number of columns. I think just with how they present that now, you know, 23 variables, you can see obviously that's the number of columns you'll have. 65 observations is going to be the number of rows you have. One thing I do like though that I will tend to use a lot is the column names just to get it. To see what are all the various variable names within it. And then you can also then within it get some descriptive statistics on the various things of it. This is when you'll start to use things like subsetting the variables. So, right, you can't get the sum of the full data set, but if you're looking for the number of fights in the number of times fights set in the whole data set, you could get that, so on and so forth. So your typical descriptive statistics, your mean, your median, your standard deviation, your min max. If you come next week, we're going to be doing a lot more hands-on operations. This is closer. This is more of a lecture that you're going to get for this one. Biggest things to take is what are functions and what do they do? How do you use functions together with arguments, and how do you create objects? When you get those three things down and an understanding of it, you can get a really good sense of this is how I actually can do things within R, and I can start to add on my own packages that have, or add on additional packages that have their own functions based in, and I can learn how to do that. Again, my name is Matt Steele. If you want to get a hold of me, you can search Matt Steele WVU, and it's got all my contact information. Next week, if you haven't signed up for it yet, we're going to be doing data cleaning and analysis with R. We're also doing it next month on Wednesday. Wednesday the 16th for data cleaning. We're going to be doing this one again on the 9th and data visualization on the end. And we're going to be doing data visualization in 2 weeks. So if you're interested in data visualization and presentation, we will also be doing those ones. If you haven't signed up for it yet, there are still spots. And then finally, we do have some additional data services workshops that if you are interested in, if you're interested in using GitHub, we will be doing one on Thursday, the 26th. So if that is something that interests you, please feel free to stand by. I will stay on for a little bit if anybody has any follow-up questions. If not, you are free to go. Thank you so much for coming.